Okay, I'm just going to quickly go over how to find primary, secondary, and tertiary for different functional groups. So there's really only three functional groups that we are going to care about this with, and one is alcohols, another is alkyl halides, and a third is amines. Okay, so these are the three functional groups we care about. Alcohols are usually OH. In organic chemistry, sometimes we put ROH. That R just means any carbon group. Alkyl halides is going to be either bromine, chlorine, fluorine, or iodine. Any halide from that second to the furthest right, let's see, yeah, second to the right column, the halogen column. These are alkyl halides. We call them alkyl halides because they're attached to an alkane, an R group, and then you have some kind of halide, usually denoted with X. And then amines are in H3, or they can be in R, H2, or in R2H, or in R3. Any of those for amines is fine. So the way that we determine the degree of substitution, that is primary, secondary, or tertiary. For alcohols and alkyl halides, they pretty much can only ever be attached to one carbon. So they're not all primary. What we do is we look at the point where they're attached and see how many carbons is that attached to. So this alcohol is attached to 1, 2, so this would be a secondary alcohol. If we look at the point of attachment, the carbon that the alcohol is attached to, and it's only attached to one other carbon, so in this case we only have one carbon that this is attached to, we would call that primary. And if it is attached to three other, so if you look at the point of attachment and it has 1, 2, 3, that would be a tertiary. We do the same thing with alkyl halides. Usually they will only have one bond, so the way that you determine their substitution is this is primary. This, because it's only bonded to one other carbon. We look at our point of attachment here, it has 1, 2, so it's secondary. And then if it looks like this, that is 1, 2, 3. This is tertiary. So we always look at the point of attachment and how many carbons is that attached to for alcohols and alkyl halides. Now amines we do slightly differently. In amines, because this can be 3 hydrogens or 2 hydrogens and a carbon, or 2 carbons and 1 hydrogen, we're actually looking to see how many carbons are directly bonded to the amine. So I think that's a little bit more intuitive. Sorry, I meant to put that as a CH3. So because we're doing it that way, this is a little bit easier. This is unsubstituted, and this one is primary because it only has 1 carbon. This is secondary because it has 2 carbons, and this is tertiary because it has 1, 2, 3 carbons. Now you can also have primary, secondary, or tertiary carbons. So if I'm looking, and you can also have quaternary carbons actually. So, oh, whoops, I didn't mean to do that. So if you have, if you're looking to see, okay, if I want to look at this carbon right here, then I look to see how many carbons is it attached to. So this carbon has only 1 attachment, so this carbon is primary. Now this carbon has 1, 2, 3, 4 attachments, so this carbon right here is quaternary. This carbon only has 1, 2 attachments, so this carbon is secondary. And then I won't do all of them. You can do them on your own if you want. This carbon is attached to 1, 2, and 3. So this would be tertiary. So similar to how we calculate primary, secondary, or tertiary with alkyl halides, that's how you can do it with carbons. All right, well, I hope that was helpful. And let me know if you have any other questions.